It's on. Okay, hello. Well, I think we've all said enough in introductions, but we're here to actually talk about and discuss AI. But I have to say, first of all, nobody has the answer yet. That this is an evolving, challenging moment that we're all in, particularly in education. And that's because artificial intelligence did not come out of the academy. It did not come out of you, not us, not anybody. It came out of a number of men in America, three people, I think more than 3 in China now, and 1 in France, who scraped and stole everything all of us have done, what the world has done in textual products, in visual and audio. They scraped it all, and now are trying to sell it back to us. And it's a very difficult and challenging moment for education because of the values that we have, golden values that we think matter about presence and cognitive capacities, etc. So although we're going to talk to you about our journey and what we're trying to do, we believe that we as educators need to harness and tame this thing called artificial intelligence in order to make it useful to us, even as it's changing by the day, right? And one of the other challenges that we face is that the main players, and whether it's Dario or Demis or Elon or Mark or Sam, are unregulated, right? There are no guardrails. We rely on these half a dozen men, in the world that control the way in which we are able to access and engage. So we have to understand that at the beginning before we even go forward. So Bill, there's 3 things we're going to do there's Matt. Oh, hi, Matt. Come on. Professor Montebello has arrived from Malta. We're starting without you, and you're going to be third, Matt. Is that okay? Right, so there's 3 things. First thing, what do we mean by artificial intelligence? Is it intelligence? What's artificial or otherwise about it? So we're going to talk a little bit about that. The second, why is it a challenge to us in the second part of our presentation in education? What are the challenges for us? I know there's a lot of early commercial attempts to create things that we use, right? And particularly in schools, you can go into a classroom now and every child is on their own app doing math or history or science on their own. And it's just something that moves very quickly and they do it on their own. It's not the kinds of pedagogy we thought was going to be the future. But these products are out there, they're everywhere. So what are the challenges for us in education? That'll be the second thing. And the last thing, as Philip said, Common Ground is an experiment in how academics engage with each other. And Philip and Tamsin have really led the redesign of it so it becomes more useful to you as professionals. Well, we've done the same. Bill and I have tried to do the same with others within the University of Illinois about how we might introduce AI in a way that meets our values as educators. And it's experimental, we're testing it. In America, you can still do what you want to do in the classroom, and there's still money available. Well, there was money available, less so money for research, but we were lucky enough to have enough research. So we are actually going to share with you live what we've tried to do, and then talk to you about the kinds of things you need to do in order to make it work for you. So they're the 3 parts of what we're talking about. But I like to show this, Bill doesn't like to show this, but I just want to remind us, right, that in the whole of human history, for most of that human history, learning and the media we used was oracy, right? But we were also synesthetic. We wrote, we did things on walls, we danced, we used smoke. We had multimodal ways of making meaning, and it was for eons, right, for most of human history. And then We invented the printing press. The Chinese did it first. We did it, the West then was able to turn it into something that we think liberated knowledge, right? Created the university and then the schools. But not so many years ago. We're talking about 800 years for the academy, 150 years for formal education, based on the text, right? But what did the text do? It opened literacy and it closed literacy. Who could read what? Who could publish? What was allowed? So it was a very specific moment in which mass compulsory education, the print literacy and formal schooling had both a positive but also a negative way of allowing knowledge, allowing truth, allowing what it was we were supposed to know happen. But now, only 50 years, and all of us have been alive since that happened, what we call the digital age. We started with the digital, and that's when we did multiliteracies, multimodality, all that. But right now, the explosion, right, is in AI. And it's a tsunami, right? It's a tsunami. And everything that went before is now affected by this explosion, this tsunami that's out there now. And we're not sure where these men that control it, whether it's in China or France or America, what they're going to do with it, how they're going to use it, and what impact it will have on us as workers and as thinkers and as parents, etc. So I just want to, a lot of people think they can ignore it. They think they can go on living in either of those. Sometimes I think I'm going to come back into the village, only speak and grow vegetables, because that's the only way to escape the challenge. But we can't do that really. And there's no going back to the traditional classroom on its own, because our children are somewhere else, our learners are somewhere else. And the gap between how children and adults make meaning is getting bigger and bigger from what we do in the classrooms that we put them in. So we have a real challenge at the moment, and I use this slide to demonstrate that this moment is different from every other moment in what it means for us as educators. Bill? I'll hand it over to Bill now.
Okay, so in this first section, and this is thinking of the interests of both conferences actually, we want to talk about the idea of artificial intelligence. And in a way, what we want to do is we want to say that in some respects, it's a terrible idea. So this is John McCarthy, who, to get funding for a workshop back in 1955, thought of this phrase. This was the title that he did, a catchy phrase to get funding for a workshop that he did. But what does it imply? Making a machine behave in ways that would be called intelligent if a human was so behaving. It's as if there's a similarity between what a machine can do and what a human can do. And what we want to do, you saw that our title was Cybersocial Learning. We want to suggest an alternative paradigm, an much older paradigm, which is the Norbert Wiener paradigm, which is not cybernetics, the whole word, because that sounds a bit too cultish, but just the word cyber. And what does the word cyber mean, and how is it different from the idea of artificial intelligence? Well, this is where Wiener got the idea from. The Kybernetes is the man at the back of the boat there. You see there's a man at the back of the boat with the oars. He's the oarsman on this boat. This is this is the Odysseus there, who's tied up to the mast, and he's got the sirens that are tempting him, and they're trying to get past the sirens without being tempted. So this is that classical Greek story. Here we are in Greece, so we need to be telling this story. So anyhow, what you do is with the oars, what you do is you're constantly adjusting. It's a feedback system. So you want to go straight ahead perhaps, but you adjust it one way, you adjust the other way. It's about this interactive relationship, as opposed to this, which implies that somehow or other the machine can replicate what humans do. No, this is a relationship between the machine and a human. So in other words, this is a kind of a dialectical thing between two different things. The machine and the ore are two different things. Now, what the cyberneticians did then, the people in the tradition of cybernetics, they drew a distinction between a trivial machine and a non-trivial machine. So this is a trivial machine. It just, you react and so on. And by the way, word processing, a lot of what we do in computers is a trivial machine. You just do something and it reacts. It's a relationship, but the machine doesn't do anything autonomously. Just to talk about what a non-trivial machine is, this is arguably the first non-trivial machine, and I want to explain to you something about it. And this becomes important for our argument in a second. The little piece that, the item that I've circled there is called the governor, wonderfully named thing. And when there was too much steam coming in, it spun out. This was a spinning wheel all the time, it spun out, and it reduced the amount of steam coming into the machine. When there wasn't enough, it dropped down, and more steam was introduced to the machine. So instead of the operator having to regulate the machine directly, the governor took on some of the roles of the that would have been the machinist's work. This is the non-trivial machine. So in other words, this has a servo mechanism. But what's most interesting around that is, firstly, this is a form of programming, and there are two concepts here, more and less, right? So in other words, what we would in human terms say more or less, more steam, less steam, the machine has taken on those commands, right? So autonomously, what a servo mechanism does, it takes on those commands. Now, one of the reasons why I'm saying this is that, in fact, what we have in artificial intelligence is a hugely elaborated version of the same thing. And what's most important as well is that this is also, we're talking, one of our themes here is education, is this is a machine that can learn. It can learn because there's less steam. It can learn when there's more steam. So it's a learning machine which is constantly adjusting to its environment because it's learning from its environment. So what we want to do is then propose a different version of a different definition of artificial intelligence from John McCarthy, which is any human meaning, for instance, an action, deduction, or a process that can be delegated to a machine to undertake semi-autonomously. It can only be semi-autonomously. And by the way, where we're going to get to in the last slide is what a hopelessly terrible idea artificial general intelligence is, and in fact artificial intelligence itself. So let me go now through a couple of historic steps, because what we want to do is say as well, people talk about this generic thing, AI, but in fact it's gone through three fundamental phases, and Mary and I are writing a book about this at the moment, and what I want to argue is these are actually different types of non-trivial machine underlying which are different types of reasoning. So this is the first, this is the Manchester one, Alan Turing, who built this Manchester one in 1948 and 1949. And already this machine, in some senses, broke the artificial intelligence barrier from the very, very beginning. And that was what the machine could do. It could find prime numbers that were not practicable for a human to find. So from the very start, in a very limited kind of way, these things were already smarter than human beings, and that's why we want these damn machines. We want these machines to do things which are better than what we can do, more efficient than what we can do, but from the very start it could do more. So the idea that we'll reach artificial general intelligence is it's measuring on the wrong scale. A very good educational example of this is Plato, which is the first computer-mediated learning system. Mary and I have written a history of this at the University of Illinois, which is where we are now. 1959 was the first of these machines, and this is a Ted Nelson thing. The ancillary to this was invented the plasma screen, and it was the first time a computer carried natural language. It's a crazy, interesting story. So a lot of what happening now in computing tracks back to this original educational application, in fact. And what we have here is a set of social relations. This is again a Plato laboratory from the early 60s. And this is, on the right, a set of logical instructions. These ones have to be around learning. But one of our arguments that Mary and I make is these are essentially deductive systems. So the code has been written. So at the very bottom of any computing program is binary notation. I'll get to that in a second. And above that are compiler languages. And what it is, it's classically logical deductive reasoning. That's essentially what it is. This is a very quick kind of schema, but one of the things we're getting to, by the way, is this latest AI is a fundamentally different genus. By the way, a little bit of cute cultural history. This down here on the right is Hal in 2001. And Hal says, as Hal's expiring, Hal says, "Take me back to Urbana," which is, where the University of Illinois is. So anyhow, the second age is data-driven systems, which it's a fundamentally different shift in paradigm. So if the first paradigm is you wrote these abstract languages which are essentially deductive, what we're doing here is essentially inductive reasoning, right? So what we're doing is classification, supervised learning is, and the classic thing is ImageNet. Fei-Fei Li is one of the leaders in this, who in the 80s, 90s, took millions and millions of images and classified them in these ways such that it was possible to identify the next image based on the classification of a huge number of images across 20,000 categories. And what's interesting is that about this is, and what's always interesting, by the way, is the human relation, this cyber relation I want to talk about, is that she used the Mechanical Turk service, which is the Amazon service, and had people in the third world labeling millions of images on the basis of the WordNet schema, which was underneath ImageNet. The data-driven system means you've got a huge amount of data, and inductively you're saying, well, because we've got a whole lot of things that look like dogs, the next image is a dog because the pixel layout is roughly similar. Or unsupervised machine learning is something where patterns emerge and then you give it a label after the event. And in education, one example of that is natural language processing in automated writing assessment. So what you do there is you get hundreds of essays, you get human graders to mark them, and when the next essay comes to the system, it says, oh, this looks like what the human graders gave an A or a B to. And this is, again, inductive reasoning. Now, what we want to argue here is that this is a fundamentally, absolutely fundamental shift, and a fundamental shift in reasoning. So, and we're going to call these text semantic systems, right? And I'm going to kind of explain why. At the very bottom, this is the mechanism. So what we're able to do is we're able to operate off graphemes. So what we have is we have stuff that's written, which is text, which is software code is just another representation, abstract language in graphemes. It can be in any language. It doesn't matter what it is. This is just a soup of graphemes, which, by the way, at the bottom of this is there's only one universal scripting system now for everything, for software code, every language that's conceivable, everything. Symbology, which is Unicode, which in the 2024 release has 154,000 odd characters. And what it does, it reduces the naming of the world to binary notation. So that's the letter A in Unicode, uppercase A. Okay, so we have these graphemes. Now, in fact, processing the graphemes, processing this at grapheme level is even for today's computational systems, unmanageable. So what there is there's a process of compression, a compression mechanism, where what we do is we reduce these things. So what graphemes consist of is phonemes, which is representations of sound, like the letter A, or ideographs, like the number 8, which represents a concept, right? But what we do is with a token, we operate actually at a semantic level. This is why we call it text semantic. Text because it operates in Unicode, semantic because it operates off these meaning units. And the reason why is, let's take the word walking, for example. Well, that's two tokens, walk and ing, which is two meaning units, right? Just from the practical side of a compression mechanism, there's no point at operating at the grapheme level. It operates at a morpheme level. So fundamentally, it's a semantic system. And in a way, what we want to argue is that it's a semantic model of the world based on all available text, which is software code in GitHub, which is logical reasoning systems, text, narrative text of all kinds from all the sources where it's been found. And by the way, at this point, math and code are writing as well. There's not a distinction between any of these things at the way in which it operates. Now, you know, this is actually a huge shift. I mean, Mary mentioned this at the beginning, which is what we had a revolution in human capacities to think and human abilities, and also, interestingly, reductions in those things, which came with print. Arguably, you know, movable type was invented in China in the 11th century, but the largely, you know, the same technology more or less was invaded in Europe in the 15th century, and that becomes a system for reproduction of text. Now, why is kind of reproduction of text important? It's ways of crossing time and space, in a way, a mechanisation of the transportation of meaning across time and space. That's actually a huge shift in the expansive possibilities for human cognitive, social, cultural activity. What's huge about this change, though, is this is the mechanical production of text, and it's the first machine to do it. But one of the things is that humans kind of do this as well, but the mechanisms by which they do it are fundamentally different. And this is our point about cybersocial. It's not replicating what humans do, it's doing different things in different ways. So one thing that AI can do, it has the whole repertoire of human textual experience there, software code, published text and whatever, which none of us as individuals can ever remotely, realistically have. So that makes it unbelievably more powerful than humans. Excuse me, I've had a terrible cold. But on the other hand, we have a whole lot of ways of meaning which it doesn't have. So to think that the one replicates the other is just not right and not true. But do you want to talk to this one here?
I want you to go faster.
Oh, you want me to go faster?
Yes.
Okay. So what it means is, look, this is just a quick summary, which is these are the differences between the two. Generative AI is empirical and statistical. You know, it's basically this vector relationship between all these morphemes along the way, and it's incredibly powerful, but it's very, very different. Whereas what we do is we think of the world, the way in which we deal with the complexity of the world is we have nouns and verbs and objects and whatever, and we can replace those things. It's a longer argument that we have in our book, but they're fundamentally different mechanisms. Just to conclude then this part, a couple of conclusions. One is that what we're going to argue then is what we have in AI is collective and not artificial intelligence. So, so what we've, you know, all this stuff is originally created by humans who wrote the texts. And one thing that's unusual about software code and published text is they're unusually carefully crafted and premeditated texts. You know, they're a sort of condensation of human experience which has been validated by publishing processes along the way. That what then happens with the corpus is that there's self-supervised and learning and pre-training that goes on. There's fine-tuning. There are humans involved the whole way in crafting this particular body of work. Then there's the meta prompt, which tells it how to speak nicely and speak objectively, and these things occasionally get out, but the companies have created those there. Then nothing happens. It's entirely inert without a user prompt. And then after the user prompt, there's a whole lot of chatbot refinements like chain of thought reasoning, agentive AI, and those have all been created in natural language by the people in the companies. So this is a hugely elaborate human construction, human technology. So this is what we wanted, this is our kind of definition then of what we have, is we have these non-trivial machines on the left who are doing a lot of internal mechanical processing, and we have, you know, all the dialogical stuff with social learning. So it's a kind of a complex model where those things go together. This is also the reason why we kind of think artificial general, like we said before, these things did things that humans couldn't right from the start. And one of our kind of definition of the limits of the absolute limits of AI is nothing can happen which is not taken through binary notation. So in other words, binary notation is using Unicode to name things in the world, and then base 2 calculation, we can find 2 of them because they're similar, and there's Boolean logic, the if-then logic as well. So in other words, that's all it can do. Now what we can do as humans is the brain is more than binary. Bodies, you know, we sense things, we feel things, we smell things, we existentially exist, but also we operate in contexts. These are purely textual machines, and that's how they work. So that's our kind of philosophical intro, which often we do this at the end of the talk, but because we've got people who are generally interested in technology as well, we thought we'd do it. But again, the takeaway is that not artificial intelligence. We want to strongly advocate for this cyber idea as an alternative. So this is on to the third section. Do you want to intro that? I'm going too slow, Mary says. No, we've got to 11. Oh, yeah. We'll be good. We'll be good. No worries. She's panicking. All right, the next thing is it's a problem for education and work and more. So firstly, what's interesting is that these AI systems of all forms, all three forms. So I just said there are these three forms. In fact, we have all of these three forms now, and even the way in which the public generative AIs work use all three systems, all three logics. Oh, and by the way, what I didn't say is that if the first AI is primarily deductive, the second one's primarily inductive, the word we're using for the third AI is abductive, which is a Charles Sanders Peirce concept, the American philosopher, which is, it's conditional, it's modal, it's suggestive in all sorts of ways that the other AIs couldn't be. All right, so what we've got is we have, in terms of education now, fundamentally these are learning systems. These are systems which teach themselves, which learn about the relationship between words through those various machine learning systems. But also we are in an environment where all our interactions involve the system learning about us. So for those of us in education, this is a profoundly important responsibility for us, more than anybody else perhaps, because these are in fact learning systems. Now, you know, what it will do, it's produced a problem for education in the sense that we have machines that are able to think and to answer questions and to write essays. And there's a British academic by the name of Mike Sharples who calls this democratising cheating. In the old days, you know, his estimate was that 15% of essays submitted to US, another piece of research actually, institutions were written by paper mills where you pay $500 to, or $100 to somebody in India or wherever to write your essay for you. Well, now it's cheaper. It democratises cheating. And look, there's a solution. Are you ready for the solution? This is the solution. So what we see happening, and this is kind of also not a joke, is a return to blue book assessments for exams, where you've got to handwrite stuff. And look, this is so problematic in a number of levels. One is, if you ask me to handwrite anything now, I can't do it because I'm so used to jumping backwards and forwards and writing something in the rough and going back and refining it. You know, one of the things is our writing processes now are so dominated by the flexibility of keyboarding that forcing you back into writing is really, really fraught and really problematic. I just couldn't do it, you know, in terms of the way in which we think while we write. So all sorts of problems with this, but also what's the model of learning here? The model of learning is just long-term memory. It's just long-term memory. It's not looking things up, it's not checking things, it's not, all the things we need to do now as sensible knowledge producers are much more broadly to be understood than long-term memory. People have tried to build up AI detectors. Basically they don't work. It's a long story, but basically they don't work. And their names are really kind of, the anti-AI detectors are kind of, their names are really revealing. Stealth GPT, Undetectable AI, Hide My AI, Bypass GPT, Clever Spinner. These are all the AI obfuscators. You can use AI, so it's a kind of an arms race. But also one of the things is, that excellent writers often get caught out because what they write is word perfect. And second language writers get caught out because they've used it just to improve their English. So everything about that doesn't solve the problem. And in our last part, which we'll come to just in a second, we'll show you what our approach to that is. This is a book published by Common Ground. It's really in the arts area, but the question now, and this is a book called The Case Against Disclosure. This is quite a radical step, which is, people are using AI all the time, and it's hard to know exactly where the AI begins and where the AI ends. And if you take scholarly work like this, what's AI good for? Well, literature search, incredible for literature search, and also review, synthesizing literature. Ideation, thinking through ideas, trying ideas out, data analysis, drafting, translation if you're not a first language speaker of the language of the school. So these are all things where it's going to be very hard to disentangle the AI from the student work, and not to use these tools is insane. So what we've done is we've prioritised transparency and disclosure ahead of detection in the work that we've done. So I'm going to go on now. You want to introduce the last one?
No, go ahead.
Okay. All right. So I'm going to just give, as a way of, we have plenty of time, by the way. You're panicking unnecessarily. I'm going to give a quick demo of the work that we've been doing before this. So this is the last part of Mary and my part of this presentation. So I am going to go and I'm going to give you a quick demo of what we've been doing. So this is, and then I'll come back with some conclusions at the end. Oh, and Mary will do the conclusions. There we go. See, we've planned this very well. So this is an environment we've called CyberScholar, and I'm showing you this live. And what we've got here is a kind of a dashboard where what a learner will only see is works and projects. But I'm an instructor, and I can manage projects. I can build knowledge bases. What knowledge bases are is domain-specific corpuses. I'm going to explain this to you in a second. I'll show you with a real example. Rubric agents is where we build criteria for knowledge evaluation. We have a survey mechanism as well, where we can do traditional kind of item-based assessment. Super admin is just managing accounts, which only a few people see. Oh, do you want to mention the platform? Mention the platform.
It's a platform pedagogy. We've actually designed the platform to do the sorts of things we need to do, because if you use Canvas or any of those other things, you can't use AI. They've put a little bit of Copilot there, and you upload and download and do a quiz, maybe a chat, but you can't really harness the AI productively in that environment. So we had to create a different pedagogical platform, and these are the elements of the platform in the first slide that Bill just showed you.
I might make this a bit bigger actually, so you can see it better, or maybe not too big. That'll do. So this is, I'm going to take you straight in and show you an example of this platform. So firstly, this is just an example. This is a multimodal writing space, and this is just an example of one of our students who's doing a project on station rotation in a client. This is one of our doctoral students about station rotation in a middle school. I'm going to give you two examples, an ed-tech example and a medical example, just to show you the range of what might be possible. The first thing is that what we want to do is we want to give you the possibility of any kind of help along the way. So let's say I'm just beginning to write it, and what I can do is I can go up here and I can build, do a couple, any number of things. Brainstorm, research, plan, expand, summarize. If I've written too much, it needs to be shortened. Translate between languages, check logical flow, advise, proofread, or just simply ask the AI a question. So what I do back here is I just select, Microsoft Innovative Educator. I want to know more about that, or I can select a whole paragraph, or I can select the whole work. So while I'm working, what we're doing is we're giving you a whole lot of well-curated tools, and behind all of these things is actually our own meta prompts, where we define what these things are. And what we define it as is brainstorming is don't write the essay, just give ideas, right? Just make suggestions along the way. So, and it will do that. So that's one phase. While I'm writing, we have this this tool called Cyber Helper. But then what I can do is I can then do a review of this work. So when I finish the work, right, I can do a cyber review. But the important thing down here is we have these different things I can do. So we have a rubric, which is the rubric agents. We have the models that are available. So one of the things is we're not tied to any particular model. So here I can select from, I'll look at it on the screen, I'm trying to look at it. Grok, OpenAI, Qwen, which is one of the Chinese ones, Moonshot, Kimi. So we're not connected to Google, Gemini 3, Mistral is the French one. The Chinese ones are pretty amazing and coming on quickly. OpenAI, NVIDIA now have one as well. So this is moving very fast. So we have access to all the latest AIs. And what's interesting is how they change. And then what I'm going to do is I'm going to start generating the review, and I'll talk a little bit more about this knowledge base in a second. But because I want that to be running in the background, I will start the review now. Now let me say what's happening is, firstly, we've built these rubric agents. So what a teacher can do, instructor can do, anybody evaluating knowledge can do, is they can build a set of rubric agents. So these are actually quite elaborated. So we want to know about previous experience. Well, this particular person has been a teacher for a while, is beginning to review it now. Evidence, which is stuff that, so we've defined all this. There's a rubric maker that we have in here as well, where we've defined these things. Evidence, concepts, theory, reasoning, critique, application, innovation. So we've built 10 rubric agents. And what happens is we built into the back of this actually a relatively old AI architecture called SOAR, S-O-A-R, where these are not just simply separate prompts. They're not 10 separate prompts, but they're prompts that all talk to each other as agents, and they understand what they've said previously in each of the bits of feedback. The other thing I want to mention while it's going in the background, so there's a huge amount of processing going on here in the background. What it's doing, it's calling out the foundation model. So we've actually, this is selected as GPT 5.1, but the class that we have here, we've built a knowledge base. So what we've done is we've put in everything that Mary and I have written for forever, plus all that our students have done. Our students are doctoral and master's students in educational technology. They've done some amazing work. So we've got about 35 million token knowledge base here, 32 million words, right? So what it's doing, it's going back into that, which is a dedicated knowledge base. It's not just the generic knowledge of the LLM. So what we do, it goes back to the LLM, the foundation model, but it prioritizes the dedicated knowledge that we've given it. These are the different components. Do you want to say something about this? Because I'm just waiting for the processing to continue.
I would say that you saw that we've allowed our students to experiment with any of the language models at all. Because partly it's letting them know that they're different and they do different things each time. But we've given them, we've selected one as the educators. This platform allows the educator, though, and this is really important, to design the whole learning experience, to design what kind of tools they want the student to use, to put their own rubric in, depending on what the subject or the content or the goal is, but to enable our learners to make the most of using what we call collective intelligence, the AI apps that are available to them, in a controlled environment, not in the wild. We don't send them out into the wild, we send them in a very scaffold environment. So what's the role of the educator now? The role of the educator is to be able to not just write textbooks and have instructional sequences, but to be able to design the ecology, the learning ecology in the context of the affordances of the AI. Very different kind of roles, and it needs collaboration, and not just one teacher, 40 kids, or one teacher, 20 adults.
So firstly, this is the review that's come back. Top strengths, areas for improvement, overall assessment, cross-cutting patterns, and then what there is for each of the criteria, there is, and by the way, these are the rubric agents here. This is what we've told the machine to do, right? But these then are strengths, weaknesses, suggestions for improvement. So it's not writing the essay for you, and it gives you a rating, right? So across all of these, you've got a voluminous kind of set of comments. And by the way, make the reliability of sources more explicit. If I don't know what that means, I can say down the bottom, explain that for me, right? So in other words, I can talk to the AI, but one of the important things that Mary just said was, this is actually talking to us as the professors, and it's actually talking to all the students who've been in our courses, because it's actually talking to the knowledge base. So what it's doing here, and what it will do, it'll give reliable references based on the stuff in the knowledge base. So see here all these references, here, well, this is all material that's coming out of the knowledge base, so it's very, very kind of explicit. There we go. It's explaining that particular concept for me. So that's, and by the way, I can also say, do this for me in Chinese. If I'm not an English language speaker or anything, I can do that as well.
Show it in Chinese.
Okay. Please respond in Chinese. And what's interesting, by the way, is it will, in terms of translanguaging, it'll actually explain how it's done, the translation as well. So in other words, you can move backwards and forwards easily between languages. Doesn't matter, you know, this is a world where it won't matter what language of instruction is anymore. I was going to just show a different example, which I'll do much, much quicker as well. So will I wait for it to respond in Chinese? I'll come back to it perhaps. This is a medical example, and here I won't go to any great detail. This is a medical case, Mrs. B, who's got jaundice. This is for medical students, where they have to write a what's called a SOAP report, Subjective Objective Assessment Plan. It's a standard formula for writing patient notes, all right? So what happens is, what we do with this is when we run this one and we do a review of the student's patient notes, what we do is we have a SOAP medical rubric, which is what do these four things mean? But then our knowledge base here is the Merck professional manual, which we have access to. Merck is a pharmaceutical company, and it's 1 million words. It's a huge medical encyclopedia, and it gives really fine-tuned responses, which helps you improve your notes. And you can then, excuse me, talk to the AI about that. Let me see if the Chinese is up. There it is. There's the Chinese version of the cyber review. So that gives you a rough sense of what it's doing. So just to come back, you know, they're the main functions, and I will jump back to the slides for Mary to conclude. Which I'll start with the analytics slide. Yep.
Yes, there's another dimension that we have, and you know, assessment is the tail of wagging.
No, go to the microphone for the recording. Just a moment. No, it's okay.
Oh, it doesn't matter. It doesn't matter. Don't worry. Assessment, the choice of assessment that you make determines the kind of curriculum that you have. We all know that. We believe in assess as you go, not assess at the end when it's too late to go back and change anything. So what we've developed is this analytical tool, which is available to all students. Every student has their own analytical tool. The teacher can access it, and we have one for the whole class. But the analytical tool has 4 parts. Before we introduced the AI, we had 3 parts, which tells you something about our pedagogy. Right? Focus. If you're in an online environment, you need to track and grade the level of commitment and engagement in the online space. So we actually have a number of, here's the kind of legend here about what goes into the focus group, and every student can see these petals growing as they engage with the work. The second part, the other part over here is knowledge. Everybody wants to know how much knowledge has been learned as a consequence of engaging. So again, each one of these petals, as the tasks are concluded, are demonstrated there. But the most important one for us is help. We expect our learners to relate with each other, to help each other, to give peer-to-peer feedback. So we don't only just get AI feedback, the students give each other feedback, and they get graded on that feedback, because if it matters to you, you have to grade it. But now we also have another component here, which is the way in which they use the AI, the cyber, the way they access the AI in their work, and in another slide we'll show you. So we're actually tracking their creativity, their cognitive demonstrations, but also the degree to which they access their AI and for what purpose. and the legend is there. So this analytical tool is really important, and the students, at first they kind of a bit confused about how much is involved, but eventually they love to see the petals grow. And we say, you can have any grade you want. You can have an A grade, a B grade, a C grade, depending on what you put into that, because we're collecting the data, we're collecting everything that you do, and you can see what result you're going to have in the end.
Next slide. Next
slide, please. But what I want to do now is just a little summarise what Bill did. He tried to show you a live demonstration of how our cybersocial works. But these four items are the things that you have to consider when you design something like this. First is you have to create the corpus. You can't send them into the AI wild. So the corpus is, what we call the RAG, retrieval augmented generation, is you, as you would have done anyway, you select the text, you select the work, you select the knowledge, and you put it into a bounded corpus as you design this. Secondly, you have to create rubrics, and we do that anyway, but the rubrics are the prompts and the degree, what the student uses to assess each other, to give feedback, to develop their work. The analytics, which I've just showed, and the fourth point is tracking that creativity. We need to be able to do that, to see how much is the human input, how much is the AI unit. Well, these are different things we have to do as educators. These are not the things we had to do before as educators, but the affordances of the digital, the affordances of the new technology allows us to rethink, as I said at the beginning, our learning ecologies, different learning ecologies. So yes, we have to work with coders, yes, we have to work with our educators, yes, we have to have a team in putting these things together, but the result is that learners are becoming prepared for the new work, the new labour force that they have to be in, becoming very closely related to what their learners are doing out in the private world as well as the public world, and it's possible to do. And this is a tracking system that we have. We have AI, there's a student work, AI feedback, peer instructor feedback, and then we have a log file data. We collect generative AI data, what were the meta prompts, the feedback, the knowledge base use, and keystroke edits, timestamps, click-through logs. So it's possible to collect the evidence of their use, and then that gives us a report about how they progress, how much is human and how much is theirs. So we've never had to do that before as part of assessment, but now we can't stop them from using the AI, but we need to create the tools that allows them to do it ethically, creatively, and to maintain the collaborative spirit that we want. Bill, that's it?
That's it.
That's it. Okay.
Yeah, while we